Good afternoon, ladies and gentlemen. Unbeknownst to you, I just recorded the notes with no sound, so I'm doing it again. Assignment on page 308 is not for today. This assignment will be for tomorrow in class. You do have a worksheet today. For those of you who aren't here, you make sure you get the worksheet from me when you get back from being ill. All right, so this is synthetic division. So this will make yesterday seem much more difficult and much more tedious than it ever needed to be. Most of you, this is going to make sense to, and you're going to use this way over long division. On the test, I specifically tell you which one to use, so you do need to know how to do long division, but you're probably going to use synthetic division from here on out. So what do we do? Well, as you've copied this down, as I've been babbling at you, hopefully you've noticed that the 1, the -5, and the 3, so this whole top row, is the coefficients from this expression up above. Where the -2 out here on the outside came from is from taking x plus 2 and setting it equal to 0 and solving it. So this is the -2 that's on the outside. Now how does this all work? Well, after you've put the coefficients in the top part and the -2 or on the outside, you're going to bring down the very first term. First number will always come down. And then you're going to take this number, this 1, times the -2, and you're going to put that in the middle. So you took that 1 times that -2, and you put it in the middle. You're going to add the columns. We always add the columns. So 1 plus -2 is a -1. I'm now going to take the -1 times the -2 and get a +2. So we took this guy here and we multiplied it. We're going to add this column, and I'm going to get a -3. I'm going to take that -3 over here to this -2. Once again, I'm going to multiply and put its answer right there in the middle, and then I'm going to add my columns. If you get a number on the end like this, and it's not a 0, so if this is something other than a 0, that is your remainder. So we have to rewrite this now and put the variables back into the problem. So just like yesterday when we were doing all this long division, and we had the long division bar, and we had stuff out here, and we had the stuff on the inside, this guy's exponent, the exponent on whatever variable that was always 1 less than what was on the inside. So we started here with a cubic, with a 3, which means this is a 1x squared. So we brought the exponent down by 1, minus 1x minus 3 plus a remainder of 9 over. What's it over? It's over this up here, the x plus 2. Okay, now do I need the 1s with this x squared and the x? No, I sure don't. Let's try another example. So I'm going to take those same coefficients, I'm going to take the coefficients that we have here, and I'm going to put them inside. So I'm going to have a 2, a -1, a 3, and a 4. I'm going to set this equal to 0, and I'm going to get x equals -1. So I'm going to put a -1 on the outside. Bring down the 2. 2 times -1 is -2. -1 plus -2 is -3. -3 times -1 is 3. 3 plus 3 is 6. 6 times -1 is -6. 4 plus -6 is -2, and that's my remainder. I rewrite this. Remember, on my variable, my exponent is going to come down by 1. So this becomes a 2. This becomes 3x plus 6 with my remainder of -2 over the x plus 1. So this is where you would stop for tonight's homework. So for our worksheet, this is where you would stop for. But we're going to continue on because what is on the next 2 slides will be part of tomorrow's lesson, which is the homework out of the book. So sometimes they're going to ask you to find all the factors. It means I need it factored. Well, I don't know how to factor x cubed minus 19x minus 30. It doesn't fit into any of the patterns that we've learned so far. But they give me that f of 5 equals 0. And when they say f of 5 equals 0, they're saying, hey, plug that 5 in for x, or in other words, x equals 5. So I'm going to put a 5 on the outside, and I'm going to take my coefficients. So my x cubed is a 1. I have no x squared term, so that's a 0. My linear is a negative 19, and then I have a negative 30. I'm going to bring down the first term, multiply. I'm going to add them, multiply, add them, multiply, add them. Since I have no remainder, because it has a 0 in the end, then that means I'm going to write it. And it means that there's no remainder. It means this may or may not still factor. And since it says factor the polynomial, I'm going to go ahead and make that assumption that it factors. And yes, it does factor into x plus 3, x plus 2. So those are the two factors I get from doing the division. But remember, they gave me a factor. They gave me this factor up here of x equals 5, which can be rewritten as x minus 5. We've done that for the last couple lessons. Let's do the same thing with the bottom one. They gave me a 4 for the outside. I have a coefficient of 2, negative 1, negative 25, negative 12. I'm going to bring down the 2. 2 times 4 is 8. Add them, 7. 7 times 4 is 28. Add them, 3. 3 times 4 is 12. Add them, I get 0. No remainder. So I rewrite the coefficients with their variables. And then I need to factor this, and it does factor into 2x plus 1 and x plus 3. And remember, I have a factor from this of x minus 4. All right, last slide. Sometimes they ask you to find the zeros, which means I've got to divide it, I've got to factor it, just like we did on the last slide, factored form, and then I've set all those factors equal to 0. So we'll start with the first one of 1, 1, negative 4, negative 4. And they tell me x equals negative 1. Now, ladies and gentlemen, could I have taken this expression up here and just factored it using grouping? Sure, I could have. But they asked me to do it this way, and that's why we're going to do it this way. So I'm going to bring down the 1. I'm going to multiply. I'm going to subtract. I'm going to add, excuse me. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. No remainder. So this is x squared minus 4, because I have no middle term because it's a 0. Now remember, we got to set this equal to 0, and I have to factor that into x minus 2 because I recognize that that's a perfect square problem. Because, you know, what are the factors of 4 that when I subtract them gives me 0 is that middle term. So I set each of my factors equal to 0. I solve them. So I have negative 2 as a 0, 2 as a 0, and this negative 1 as a 0 because they gave that one to me. My 3 zeros, 3 answers for a cubic. Let's take this 4th degree right here, and I get a 1, a negative, I get a 0 because there is no cube, a negative 5 for the square, a 0 for the linear piece, and a 4. I put a 1 on the outside. I bring down that 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. Negative 4 times 1 is negative 4. 0 plus negative 4 is negative 4. And negative 4 times 1 is still negative 4. And when I add those together, I get 0 as my remainder. So I rewrite, so I get x cubed plus x squared minus 4x minus 4 equals 0. Now, ladies and gentlemen, this is a cubic. It's not a perfect cubic like the ones we've done in the past, but I need to recognize that it's 4 terms. I should try to factor by grouping. So if I factor by grouping, I take these first 2 guys, remember, and I factor out what they have in common. They're GCF, which is an x squared, and I'm left with x plus 1. I look at the second 2 guys right here, and I say I can factor out a negative 4 from both of them. That leaves me an x plus 1. And then if you remember from factoring by grouping, we are looking at the fact that they both have a parenthesis that's the same. So I'm going to factor it out to the front. And what's left is an x squared minus 4. Now, ladies and gentlemen, because we just did this same part in the problem right before this, I need to recognize that x squared minus 4 is a perfect square problem. So that's going to factor into x plus 2, x minus 2. And then, as per usual, x plus 1 equals 0. X plus 2 equals 0, x minus 2 equals 0, so x equals negative 1, x equals negative 2 and x equals 2. So we have 4 factors. There are 3 of them, and the other one is up top. All right, I will see you all tomorrow.